Solve the following system of equations using the inverse matrix method. So given here, we have three simultaneous equations with unknown x, y, z. So for this equation, we are going to form out our matrix equation. So for the coefficient x, y, z, 1, -3, 1, we'll put in matrix form. Second equation here, 1, 1, 1. Third equation here, 2, -1, 1. Times with the unknown matrix, which is our unknown here, x, y, z, equals to the answer, -12, 0, -8. So for this matrix, we will denote it as matrix A. For this unknown matrix, we will denote it as X. And for this matrix, we will denote it as C. In order to solve this linear equation, means we need to find out what is our unknown matrix here. So in order to find out this X, we need to times A inverse with A. So that A inverse with A will give us identity. So for the right hand side, A inverse will time with C. Then we continue simplify. Identity time with unknown matrix will give us unknown matrix. So we can obtain our unknown matrix x, y, z by using A inverse times C. So now we're going to find our A inverse. So in order to find our A inverse, we can choose adjoint method or ERO. So for here, we will choose adjoint method where A inverse, by using adjoint method, it will be 1 over determinant A times adjoint matrix A. So we're going to find out what is our determinant A. So A11, element 11, which is 1, time with is minor, then minus element 1, 2, -3, minor 1, 2, and then plus element 1, 3, which is 1, minor 1, 3. Then we're going to perform our minor 1, 1. So minor 1, 1 means eliminate first row and first column. So here we will have 1, 1, -1, 1. So in order to perform 1, 2, minor 1, 2, and minor 1, 3, we can carry on in alternative way where we can copy and paste. Then this element at the front here in and go to the out here, last part. So copy and paste in and out. Then we see the element that haven't cancelled out here is 1, 2. So here is our entry 1, 2. Then we're going to calculate our minor, which is AD minus BC, 1 minus -1. Then here negative become +3, 1 minus 2, -1 minus -2. So here will give us determinant -4. After we getting our determinant, now we proceed to find out what is our adjoint matrix. So for adjoint matrix A, it will be equivalent to cofactor transpose. So cofactor will be equal to the positive or negative minor, depends to the position. So positive 1, 1, negative 1, 2, positive 1, 3. Then negative 2, 1, positive 2, 2, negative 2, 3, positive 3, 1, negative 3, 2, and then positive 3, 3. So we continue with finding our minor here. So minor 1, 1. It will give us 1, 1, negative 1, 1. So copy and paste, in and out. Those vertically is 1, 2. So repeat this process for minor 2, 1. For minor 2, 1, we will eliminate row 2, column 1. So it gives us negative 3, 1, negative 1, 1. Copy and paste, in, out. Those vertically is element 1, 2. Lastly, we going for minor 3, 1. So minor 3, 1, eliminate row 3, column 1. It will give us negative 3, 1, 1, 1. Copy and paste here. Then this one starting in, going to out, last here. So vertically, the number that haven't cancelled out here is 1, 1. Then we perform our concept of minor, which is AD minus BC. So 1 minus negative 1, it gives us 2. And then 1 minus 2, negative 1, negative, negative become positive. And then negative 1 minus 2, negative 3. Negative 3 minus negative 1, negative, negative become positive 2. So 1 minus 2, negative 1. And then negative 1 minus negative 6. So it becomes 5. Out here negative. So negative 3 minus 1, negative 4. So here is 0. Here 1 minus negative 3 will be 4. So after finding all these cofactors, we're going to transpose. So transpose means row become column. So first row here will become first column. Second row will become second column. Third row become third column. Therefore, finally, we can obtain our A inverse, which is 1 over determinant times with the adjoint method that we found just now. Multiply negative 1 over 4 into the matrices here. So here is our inverse matrix. So after we finding our inverse matrix, we can substitute into our unknown matrix here. X equals to A inverse times C. So now we can solve our linear equation where X equals to A inverse times C. X is denoted our unknown matrix x, y, z. And then A inverse that we found here and then matrix C here will be denoted by negative 12, 0, negative 8. So perform this multiplication. It gives us negative 2 row times with the column. So row here is 3, 0, 0, so it gives you 3. So this row with this column here will equals to negative 9, 0 plus 8 will give you negative 1. So finally, we can solve this simultaneous equation where x is equals to 2, negative 2, y equals to 3, and z equals to negative 1.